IP address of PCB is 10.1.1.2, IP address of PCC is 10.1.1.3, and IP address of this machine is 10.1.1.4, right? So how switch can perform unicast between these users? Like if 10.1.1 want to communicate with 10.1.1.4, right? How switch will forward traffic or frame?
by by using MAC table.
MAC table. That means
Yeah.
switch all switch will have one MAC address table, right? So let's say this is MAC address table of this switch. MAC address table. Now question is how switch is going to maintain this MAC address table? How switch is going to make entry in their MAC address table?
When the switch uh,
Frame
received the frame
user.
from the users to these boards,
Okay.
it will first time it will broadcast all whatever.
No, when
Um,
switch will receive any frame on any interfaces, first of all switch will make one entry in their MAC address table, right? It will learn source MAC address, right? Let's say if 10.1 want to ping 10.4, ping 10.1.1.4. So here in the packet source MAC address will be A and destination MAC address will be B. When switch will receive this frame, right? First switch will learn source MAC address, right? When switch will receive this frame, switch will receive this frame on 0/1 interface, right? So it will learn source MAC address on this interface. That means a device is connected on 0/1 interface whose MAC address is A, whose MAC address is A, right? So it will make one entry in their table that uh, I am receiving frame on 0/1 with source MAC A, and this interface is member of which VLAN. So let's say VLAN 1. Okay, and how I have learned this MAC address, static or dynamic? So we have two methods. Statically also we can make entry, right, manually in their MAC address table of switch. Means we can bind MAC address with interfaces statically also. Otherwise now switch is learning dynamically. So let's say it is learning dynamically. So method of learning this MAC address is dynamic, right? So four information will be there, right? Interface, then MAC address, then VLAN information, and then method, how I have learned it. Okay, so interface is 0/1, MAC address is A, VLAN is let's say 1 by default, and method is dynamic. After that switch will check what is destination MAC address in the frame. So destination MAC is B. Again switch will check their MAC address table to forward frame to the PC whose MAC address is B. So it will look up their MAC address table. Is there any entry available for B MAC address? No. Then switch will broadcast it. Then switch will forward one copy of frame from their each interface except receiving interface. Means it will forward one copy of frame from 0/2, one copy from 0/3, and one copy from 0/4, right? So first mechanism of switch is, or we can say first function of switch is learning source MAC address. Okay, yes or no? So
Yes,
okay,
yes.
when switch will forward one copy of frame from its each interface except receiving interface, what PCB or PCC will do with frame? It will simply discard it, right? Because destination MAC in the frame is B, and destination MAC will be not B, destination MAC will be D, right? D. Right? So computer B will discard the frame, computer C will also discard the frame, and this machine will generate what? Reply. So in the reply again source MAC will be D and destination MAC will be what? A. Again PC will forward this frame to switch. Switch will receive it on fast Ethernet 0/4. Again first switch will learn source MAC address. This time interface is 0/4, MAC address is D, and VLAN is again 1, and I am learning it dynamically. Then switch will check what is destination MAC. So destination MAC is A. Again switch will check their MAC address table to forward this frame. So yes, this time one entry is there inside the MAC address table of switch for a MAC address, right? Exit interface for a MAC address is 0/1. So this time switch will perform unicast. It will forward frame from 0/1 interface only. Getting my point, guys? Clear? So MAC address table, and these MAC addresses are, you can see, method is static. How switch have learned this MAC address? Statically. Actually these MAC addresses are, not for the forwarding frame of user. This is for internal process, like for CPU, like for protocols which is running on switches, DTP, VTP, STP. Okay, so inside the MAC address table of this switch, we are able to see some static MAC addresses and some dynamic MAC addresses. Like this switch have learned these MAC addresses dynamically on 0/1, 0/3, 23, 24, 22, 21, right? So total number of MAC addresses in the MAC address table is 28. Okay, so actually a device is connected on 0/1 port. Whose MAC address is this one? Whose MAC address is this one? So interface status, and we can say include connected. So devices are connected on these two interfaces, 0/1 and 0/2. And so MAC address table, inside the MAC address table you can see switch have learned two MAC addresses dynamically, one on 0/1 and one on 0/2. This is MAC address of router 1 on router 1. So interface fast ethernet 0/1 include, you can see this is MAC address of R1. So switch 2 have learned this MAC address on which interface? 0/1 interface, right? And MAC address of switch 2, router 2. So interface F0/1. This is MAC address of router 2 in last 31. So switch 2 have learned this MAC address on 0/2 interface. Both interfaces are in which VLAN? VLAN 1. And how switch have learned this MAC address? Dynamically, right? And so MAC address table we can say dynamically also, like I want to check only dynamic entry. Okay, so this is MAC address table. These are two MAC address which switch have learned dynamically. Okay, now if this switch need to forward frame between these two MAC addresses, it can perform unicast. It can perform what? Unicast. Yes or no? And so interface fast Ethernet 1/0/1 1, and here we can say include, let's say, packet input. Here we can see how many packets input are there and how many packets output are there on this interface. So guys, what I am trying to say is, see, packet input is increasing automatically, right? On this interface, if you will check packets input include, so see this number is increasing. 84, after some time you will see 85, right? After some time you will see 86, right? And packet out, if you will check output packet, how many packet have out from this interface? Packets output. So 477 packet have out from this interface, and this value is also increasing. Now 82, 84, right? 85. That means some protocols are by default running on switches, right? And routers are also sending some packet by default, because of that's why switch is receiving some packet on both interface, on 0/1 and 0/2. On both interface, which is receiving some packet also, and which is forwarding some packet also from this interface. That means some protocols are by default enabled, like keep alive message, CDP protocol, clear MAC address table. Again, you can see switch have learned MAC address on 0/2 interface. It have learned MAC address on 0/1 interface. So in real time, right, even user will not forward traffic. If user is forwarding any kind of traffic, even keep alive message or any other messages, switch will learn MAC address of user, and it can perform unicast. It can perform unicasting. So it can perform unicasting. 1 minute, guys. Okay, now question is, this switch can learn how many MAC addresses? This switch can learn how many MAC addresses? So for that, what we can do, we can check so MAC address table, and we can run this command, so MAC address table count. So total number of MAC addresses that this switch can learn, means space, total space is available on this switch for learning MAC addresses 6045, around 6000, right? It can learn around 6000 MAC addresses in their MAC address table. It can learn 6000, around 6000 MAC addresses in their MAC address table. And you are allowed to change this value, right? This is actually multi-layer switch, L3 switch. This switch can perform routing also, and this switch can perform switching also. So by default, this switch is performing both, right? Routing is disabled, but still we have some space for routing. We have some space for switching. So let's say I want to use this switch only for switching purpose. right? Then I can increase the space for switching purpose. We can decrease the space for routing purpose. So now total number of MAC address is 2, and the dynamic MAC address is 2, static MAC address is 0. Static MAC address means manually we can bind MAC address, like let's say this entry, so MAC address table, this entry dynamic, this entry is not permanent. Switch will keep this entry in their MAC address table for 300 seconds only. After 300 seconds it will flush this entry, right? Because it is dynamic in nature. But if you will configure this MAC address on this interface statically, then entry will be permanent. Entry will be permanent. So for that, what I can do, I can copy this MAC address. I can copy this MAC address. After that, in config mode, I can say MAC address table static, and after that address, so this address, and then VLAN information is, let's say, VLAN 1, and then on which interface you want to assign this MAC address. So on fast Ethernet 1/0/1, that's it. Now so MAC address table, so now you can see this MAC address is, method type is now static. So this entry will be now permanent. This entry will be permanent. So MAC address table aging time. This is MAC aging time for VLAN 1, and actually we have only one VLAN on this switch now. So that's why we are able to see MAC aging time for VLAN 1 only, right? So MAC aging time is till when switch will keep entry in their MAC address table. And we can change this MAC aging time also. We can change this MAC aging time also on switch. Even we can check the interfaces through MAC address, right? Like this MAC address is assigned on which interface. Let's say, so MAC address table, inside the MAC address table, let's say I have one MAC address of router 1. This is MAC address of router 1. I want to know this MAC switch have learned this MAC address on which interface. Switch have learned this MAC address on which interface. So what we can do, we can say so MAC address table and then address. After that, put the address, this address. So these are some basic verification command, right? Like you can see now, this MAC address is assigned on which interface? On 0/1. How? Static. So for permanent entry, what you will do? You can configure a static entry in the MAC address table. Now sometime, in how interviewer can ask you question. Interviewer can ask you that switch is performing unknown unicast flooding, right? How to reduce it? Unknown unicast flooding means whenever switch will receive a frame, right, and switch will not find any entry for destination MAC address. Let's say in this scenario 10.1 want to communicate with 10.4. So source MAC will be A and destination MAC will be D. Or 10.1 want to communicate with, let's say, 10.2. So destination MAC will be B. User will forward traffic to switch. Switch will receive frame on 0/1. It will first learn MAC address table. So still one entry is there, right? So it will update the entry. Let's say for this entry MAC aging time is 200 seconds, right? That means after 200 seconds it is going to flush this entry. Okay, so Again, if switch have received one frame with source, same source, so it will reset the timer. It will again set MAC aging time 300 second. After that, it will check destination MAC. So destination MAC is B. Again, switch will look up their MAC address table. Inside the MAC address table, entry is not there, so it will forward one copy from its all interface except receiving interface. This is unknown unicast flooding. Guys, if you want to reduce this unknown unicast flooding, what you can do? First option is we can configure a static entry inside the MAC address table for all devices. So that entry will be permanent. Entry will be there inside the MAC address table permanently. Right? So switch will never perform a non-unicast flooding. Another method is we can increase MAC aging time. So if I will increase MAC aging time, see now switch is going to flush this entry for after 300 second. Means after 300 second, if switch will receive frame where destination is A, again switch will perform a non-unicast flooding. Right? So what will happen if I will increase this MAC aging time? We can, with by increasing MAC aging time, we can reduce a non-unicast flooding. We can reduce a non-unicast flooding.
What is
And
the
then
limit for this increasing this time? How much?
MAC aging time.
Yes.
Okay, MAC address table aging time, this one, in second.
Okay.
Okay,
Okay.
let's say I want to configure 500 second. So now MAC address table aging time, you can see 500 second. For a particular VLAN also you can increase or decrease MAC aging time. This is for all VLAN, right? And for particular VLAN also, let's say here I have one VLAN 10 exit and interface fast ethernet 1/0/1, or let's say 2 switch port access VLAN 10. This interface is now in VLAN 10. So MAC address table aging time for VLAN 1 as well as for VLAN 10. Now MAC aging time is what, 500, but let's say for VLAN 10 only I want to set MAC aging time, let's say 300 second or 500 second or 1000 second. So we can do that also. MAC address table aging time, and let's say 1000 second for which VLAN? For VLAN 10 only, right? So MAC address table aging time. Now you can see for VLAN 1 MAC aging time is 500, except VLAN 10. For all rest VLAN MAC aging time is 500 second, and for VLAN 10 MAC aging time is 1000. So interviewer can ask you this question also, that for particular VLAN can I increase or decrease MAC aging time? So yes, we can. Can we increase a space for MAC addressing? So yes. On multi-layer switch, yes, we can. Any question from MAC address table? So MAC address table, we can use address command here. We can use aging time. We can check count. We can say dynamic or static, which type of addresses you want to check. Then you can use interface also, like on a particular interface I want to check switch have learned what MAC address. So MAC address table interface fast ethernet 1/0/1. So it will show me what is the MAC address on this interface. Then we can use VLAN also. Let's say VLAN 10. So it will show me MAC address table for VLAN 10 only. These MAC addresses, as I told you, these MAC addresses are for internal process. So VLAN is all. So this is a static MAC address for all VLAN, right? So that's why we are able to see these entry. Yes, boss. You can.
So these MAC address, they are for which equipment? The CPU ones.
These are static.
Yes.
These are for internal
Static,
process, like
the
for
replacement.
a protocol. By default, a spanning tree protocol is running here, so a spanning tree protocol, right? So STP, how STP will forward their packet, how EAGRP is forwarding their hello packet on the multicast address. In the same way, a spanning tree protocol is also going to forward their messages on layer 2 multicast address, right? So those MAC addresses are reserved for protocols which is already running on switches.
Okay. Got it.
Right, maybe this MAC address is for a spanning tree protocol, this is for another DTP protocol or VTP protocol for other protocols. Like here what we can do, we can run one more command. So yes,
These CPU MAC addresses will be same on all the switches?
CPU on all Cisco switches, and again on the same platform only, right? On layer 2 switches it will be different, on layer 3 switches it will be different. If we will talk about same series of same platform of switches with same iOS version, right, then
Mhm.
definitely we will have same number of and the same mac static MAC addresses entry inside the MAC address table.
Okay. Sir.
So SDM preferred, so you can see this switch can learn how many MAC addresses, 6000. This switch can learn how many route, IPv4 route, how many multicast route. So as I told you, this is multi-layer switch. So on this switch we can perform routing also, we can configure access control list also, we can configure policy based routing also, right? So we have a space for each services. But let's say I want to use this switch only for switching purpose, then why I will allocate some memory for to store IPv4 route, right, or to store IGP route, multicast route. So we can change it, we can manipulate the space of switches as well with the help of SDM. SDM stands for switch database manager. It is used to SDM is used to manage memory of multi-layer switch. Memory of multi-layer switch. Actually there are three templates of SDM. One is default templates, default template which is by default running default template. Another one is VLAN template. So VLAN template is going to allocate all memory for switching purpose, for switching only, right? And then we have third one is routing. So if we will configure routing template, then all memory on the switches will be almost all memory, not all memory, completely all memory, almost all memories will be allocated to routing for the routing purpose. Layer 2 or layer 3 forwarding are supported here. Okay, so let's say I want to use this switch only for switching, right? I don't want to allocate any memory for routing. So here in global config mode I can run SDM preferred command, and then we can say what VLAN. Once I will hit enter and I will reload the device, hit enter, and now reload the device. If you will reload the device, automatically a space for storing MAC address will increased. Let me show you. Change running SDM preference have been stored but take effect until next reload. So that's why I have reload the device.
So we're gonna see during the switching module, the stacking module tutorials.
Stacking, combining switches.
Yeah, yeah. Practically,
No,
we're gonna do it during
no.
the tutorials.
In switching module, first now we are learning MAC address table, right? After that we will learn VLAN, trunking, DTP protocol,
Okay,
BTP protocol, spanning tree protocol, Ether channel, and that's it.
okay.
Okay. So now if you will check again, enable. So MAC address table count. Now you can see this switch can learn how many MAC addresses? 12,000, around 12,000, right?
Thousand.
Clear? Any question in MAC address table? How switch build MAC address table, right? How to make a static entry? How to change MAC aging time? What is MAC aging time? And see, let me check, is there any other feature? So MAC address table in verification command, you can use these all, right? uh, Feature like address, you can check MAC address table with the help of address. We can check aging time, we can check count, dynamic on interface. This is not for you. Then we can check a static entry, we can check MAC address table with the help of VLAN. Okay. And in while configuring MAC address table, and let me put question mark here, we can configure MAC aging time, we can configure static entry. Done.
Do we have any command to check this hardware details of this particular switch? Like
Hardware details
means how many ports are there, and
how many ports you can run. So interface status command.
okay.
With the help of this command you can check you know, how many ports are connected with device, or how many ports, you know, a status can be connected, a status can be not connect. That means no any device is connected on this interface, or a status can be disabled. Disable means port is shut down.
To know
Do
the
we have
serial
VLAN
number,
information? To know the serial number you can run show version command na? To check platform, IS version, license, or whatever. Yes,
switch model,
switch model is here, 3750. Platform, IS is 12.2. And after that you have run many command like so CPU. CPU command is not here. So process,
ROM utilization,
CPU, like this. RAM,
memory,
RAM memory. I don't know what is the command to check RAM memory. You can Google it. What is the command to check RAM memory on Cisco switch? Right? You can Google.
And how to make a
Every
cluster?
command is available, right? Right? But it is difficult to remember all command at a time. Yes.
How to make a clusters?
I think it is so memory. I think it is so memory. 2
So if anyone can read these, you can read, guys. I don't know how to read. Free, lowest, largest, total, head.
Yes, you have a total is something like 8, and
Can we upgrade the RAM for switch?
Physical RAM. Of course we can. Of course we can increase the RAM, we can increase the hardware, we can replace card. These are possible.
Can you give show inventory?
So after, so there are lots of commands. See how many commands are there. Error disable, ether channel, you will learn these commands. We will cover only part of routing switching, all the commands related to routing switching. Okay, yes. So inventory, any other command?
How to check
This is a serial number.
supported here? VLAN supported here. Number of
How
VLANs.
many?
How many number of VLANs?
So how many number of VLAN you can create on switch?
Hmm.
4096.
How to check that one? Do you have any command for that?
So VLAN brief. Existing VLAN. No, I think there is no any command like that. No. Here like this we can check VLAN and then we can put question mark VLAN.
No.
See how many VLAN I can create here.
Interface VLAN, VLAN ID, or VLAN range?
Interface
VLAN, VLAN ID or
VLAN.
VLAN range? VLAN range.
Like this also we are able to see same range. So definitely I think so all switch will support the these all VLANs. We can create these all VLAN on switches. Now next topic is VLAN. So guys, what is VLAN? What is VLAN? So VLAN brief. By default, all interfaces of this switch belongs to VLAN 1,
Native VLAN.
native VLAN. Okay, forget about native VLAN. Let's say VLAN 1. What is VLAN? Why we come up with VLAN? VLAN is used to break broadcast domain. VLAN is used to break broadcast domain. See, by default, all interfaces belongs to same VLAN. That means all interfaces are in single VLAN. Let's say this is switch, right? And here I have one computer. Here also I have one computer. 4 computers, let's say, are connected. A, B, C, and D. If computer A want to forward some data to computer D, and let's say switch don't have any entry in their MAC address table for D destination, so this switch will perform unknown unicast flooding, means it will forward one copy to this PC also, one copy to this PC also, and one copy to this PC also, right? Like this, let's say this switch is connected with 50 number of users or 50 number of computers. So whenever switch will perform unknown unicast flooding, 50 computers will receive unnecessary message, right? Unwanted frame. That PC will receive it, it will check destination MAC, and then it will discard it. Getting my point? And whenever switch also forward a frame from their interfaces, which uses their CPU. So let's say we have multiple switch. Switch 1 is connected with switch 2. Switch 2 is connected with switch 3. Right? And all switches are connected with lots of computers. So by default, these all machines are in single VLAN, right? In VLAN 1. So if this machine will generate a broadcast, all other PC will receive that broadcast. All other PCs will receive that broadcast. Or if switch 1 will perform unknown unicast flooding, right? That means switch 2 will also receive that broadcast message, unicast message, and it will forward one copy from their all interfaces. Switch 3 will also forward one copy from their all interfaces, right? So this is problem. If my broadcast domain is large, right, network performance can be reduced. Network performance can be reduced there if broadcast domain is large. So to divide this broadcast domain, we come up with VLAN concept. We come up with VLAN concept. Actually,
What is the difference between unicast flooding and broadcast? When switch does
both are same. Both are same. Difference is in broadcast, destination MAC will be broadcast. In unicast flooding, destination MAC will be unicast.
okay.
Okay, so see, in this scenario, let's say 10.1 want to communicate with 10.4. So 10.1 will generate ICMP packet, it will encapsulate with IP packet. After that, at layer 2, source MAC will be A, destination MAC will be D. It will forward frame to switch. Switch will receive it on this interface. Now switch is not going to check their entire MAC address table. Switch will not run show MAC address table command. Switch will run show MAC address table VLAN, and VLAN ID will be the VLAN of receiving interface. This interface is member of which VLAN? Okay, so this interface is member of VLAN 1. So switch is going to check their MAC address table like this. So MAC address table and VLAN 1. Getting my point? Okay, so if all interfaces are in same VLAN, then definitely switch will forward one copy to PC B also, PC C also, and D also. Now let's say I have separate these two interfaces in VLAN 10 and these two interfaces in VLAN 20. These two interfaces in VLAN are in VLAN 20 now. Now if let's say 10.1 want to communicate with 10.2, source MAC A, destination MAC B. PC will forward frame to switch. Switch will receive it on this interface. First it will learn MAC address. A MAC address on which interface? On 0/1 interface, which is member of VLAN 10. After that, switch is going to check what MAC address table of VLAN 10. If switch will not find any entry in their MAC address table for destination device, then it will flood this frame in VLAN 10 only. In VLAN 10 only. That means switch will forward one copy from those interfaces which are member of same VLAN, which are member of VLAN 10. So it will forward one copy from this interface only. So this time this machine and this machine will not receive, this frame. It's a non-unicast frame. Switch is not going to forward frame from the port which are member of VLAN 20. So this is how we can reduce broadcast domain with the help of VLAN. Clear? One VLAN means one broadcast domain. One broadcast domain. And you know what is broadcast domain? That's why we called, all ports of switch belongs to single broadcast domain. Reason is all ports of switch belongs to single VLAN. Okay. Now how to create VLAN on switch? Simply you can run command VLAN and then VLAN ID. After that exit. Have router 1, router 2. Let me access router 3 and 4 also. So MAC address table dynamically. Okay, this is MAC address table of switch 2. Let me assign one IP address on R1 interface fast Ethernet 0/0. Sorry, not 0/0, 0/1. 10.1.1.1 255.255.255 dot, let's say 0. Exit.
This is 0/2.
Router 2 fast Ethernet 0/1 is connected with switch 2 na. Here
Okay.
see the topology. Okay, now you can see MAC address table is updated, and all interfaces are member of VLAN 1. We can run show VLAN brief command also, so VLAN brief to check. Now on this switch, I want to put these two interfaces in different VLAN. These two ports should be in, let's say, VLAN 10, and these two ports should be in VLAN 20. So on switch number 2, simply I will run command VLAN 10 and do show VLAN brief. We don't have VLAN 10 here. Why? I have run this command VLAN 10, but I don't have VLAN 10 on this switch. Actually, until and unless you will not exit from here, VLAN will not create, right? So once I will exit, and then I will check do show VLAN brief. Now you can see we have VLAN 10, and we can configure name also, like VLAN 10 and name. Let's say Sony. Do show VLAN brief. VLAN 10 is created, name is Sony, and this VLAN state is active, and there is no any interface in this VLAN. There is no any interface in this VLAN. So now question is how to assign interfaces in VLAN. Simply you will run command on interface fast Ethernet 1/0/1 switch port access VLAN, after that VLAN ID. Right, this command will put this interface in VLAN 10. Do show VLAN brief. You can see now this interface is in which VLAN? In VLAN 10. In the same way, I want to put one more interface in VLAN 10, 1/0/2 switch port access VLAN 20 and do so VLAN brief. Sorry, I have assigned this interface in VLAN 20 now. VLAN 10. So these two interfaces are in VLAN 10. In the same way, let me create VLAN 20 name, and two different VLAN cannot have same name, right? So name of VLAN 20 should be different from VLAN 10. Okay, so let's say name of this VLAN is Sony G, and switch port, sorry, interface fast Ethernet 1/0/3 switch port access VLAN 20 exit interface F1/0/4 switch port access VLAN 20 and show VLAN brief. So 0/3 and 0/4, these two interfaces are in VLAN 20 in Sony Z, and 0/1 and 0/2, these two interfaces are in VLAN 10. So when 10.1 means router 1 ping, let's say 10.1.1.2 means router 2, how switch 2 is going to check their MAC address table? Guys, this is interview question. This is interview question. Interviewer can design this topology in front of you, and they can ask you router 1 want to ping router 2 or PC 1 want to ping PC 2. How switch is going to check MAC address table, or what command switch is going to run to check their MAC address table? So switch will run which command? So MAC address table VLAN, and what will be VLAN ID?
10.
10. Right, and after that here for better output we can put dynamic, and then we can say VLAN 10. Okay, so clear MAC address table dynamic. So now if I will put this command, so MAC address table dynamic VLAN 10. So we have one MAC address on fast Ethernet 1/0. So if 10.1 want to ping 20.1, ping 10.2, ping 10.1.1.2. So switch will check their MAC address table. In their MAC address table, you know, one entry is there, so it will definitely update this entry. It will reset, update the entry means it will reset the MAC aging time. And after that, switch 2 will perform unknown unicast flooding. So this time switch 2 will forward frame from which interface? From how many interfaces, guys? It will check this. So VLAN brief. Receiving interface is member of VLAN 20. How many interfaces are there in VLAN 20? 2. So it will forward frame from these two interface, but this is receiving interface. Except receiving interface, it will forward the frame from all interface. That means it will forward the frame from 0/4 only. So this time router 3 and router 4 will not receive frame of router 1. Now problem is ping 10.1.1.2. I'm able to ping router 2. Yes, I am able to ping router 2, but am I able to ping router 3? Ping 10.1.1.3. Now this is problem. Now two different VLAN cannot communicate with each other. Two different VLAN cannot communicate with each other
by default.
by default. So here what we achieved, we divide broadcast domain, and now we need to make communication between two different VLAN, right? Because these users should be able to communicate with each other. Now my broadcast domain is small, that is good, right? But these users should be able to communicate with each other, right? So now next topic is inter VLAN routing. Okay, any question in VLAN? And we can create, you know, multiple VLAN also with single command. VLAN, let's say I want to create VLAN 32, VLAN 50. So I can note a space, VLAN 32, 50. VLAN, oh, I am on router 1. On switch, we can create multiple VLAN as well, like this. Do so VLAN brief. You can see VLAN 32, VLAN 50, all VLANs are created over here.
Any VLAN types is there? VLAN types.
Yeah, we will discuss VLAN type also. VLAN, let's say 62, 100, and after that 101. We can create VLAN like this also. Like this. So you can see. (100) and 101. By default on switches, how many VLAN are there? 4 and VLAN 1. Means total number of, by default total number of VLAN exist on switches is 5.
5.
And how to check how many VLAN are there on switch? So VLAN summary. So total number of VLAN on the switch is 60. Clear? And you know, we can check VLAN with the help of name also. So VLAN name and Sony. So it will show me so VLAN brief. Okay, S is capital. Okay.
So last time I wanted to send one switch configuration to one of my colleagues via Notepad.
Okay.
I copied the show running configuration, but VLAN information was not there. So I don't know how to transfer VLAN information
We,
to.
switch store VLAN information in their flash memory. If you are running so run, right, that means you are checking which memory, RAM. Running configuration is stored in RAM, but switch not store VLAN information in RAM. If you will check flash memory of this switch, so flash. So inside the flash, you can see there is one file with VLAN.dat file, right? With name VLAN.dat. Actually, this file stores VLAN information. If you want to delete VLAN, you have to delete this file, right? If you will run no VLAN 10 or no VLAN 30, right? Again, if you will reload the switch, automatically VLAN 30 will be created on switch, right? Because still VLAN 30 is there in flash memory. So in running configuration, you will not see VLAN information. So run. You can see, guys.
Yes. So now how to send this file to another colleague so that he can import in the switch if it's no
For
switch.
VLAN information, you have to run this command, so VLAN brief. To share VLAN information, you need to run this command and just copy the configuration and you should share with your colleague.
This one.
Hmm.
Show VLAN brief. Okay. Ah. So that means the colleague need to configure it manually or just copy this one output and paste it?
No, they have to create VLAN manually, or you can.
Ah,
Otherwise, we can send that VLAN dat file through the TFTP, na? Is it possible, right?
Yeah, that is also possible. But he want to copy the configuration and
No,
want
no,
to
actual,
share.
yes, actually, he want that configuration means in the dat file that configuration is there, na? That if you
One minute.
show flash,
yes. If that is possible to export it and send to my colleague and he receive an import, if that is possible, that would be
yes,
great because if we have a lot of VLANs and
yes.
not possible, easy to write everything manually.
Yeah, through TFTP you can do that one.
Okay, then you can share VLAN.dat file through TFTP or FTP. So VLAN. So VLAN. Okay. Now, how to delete VLAN? Simply you will run no VLAN 30 command. But as I told you, this command will not delete VLAN permanently, right? If I want to delete all VLAN on this switch, I can say no VLAN range 2 to 40, let's say, or 2 to 200, like this. If I will try to remove VLAN 1, so we cannot remove VLAN 1. Default VLAN 1 may not be deleted. Now we have some VLAN states. First one is active, suspend, inactive.
Gee, what is that difference for this VLAN 1 and native VLAN?
VLAN 1 is native VLAN. When you will learn the concept of native VLAN, right, you can configure other VLAN also as native VLAN. VLAN
Yes.
10 can be also native VLAN.
Yes, yes.
Who told you? By default, VLAN 1 is native VLAN, right? This is not like VLAN 1 is native VLAN. This is incorrect point, okay? By default, VLAN 1 is configured as native VLAN. So don't worry, you will understand the concept of native VLAN. What is native VLAN, right?
Okay.
Why
Okay.
we need to configure it on switch. When we will discuss trunk, we'll discuss native VLAN, right? That is concept on trunk link. Okay, so state case we have four states of VLAN. Now you can see on switch so VLAN brief. State is active. Status of VLAN 1, VLAN, this VLAN is also, let me create one VLAN here. I have deleted all VLAN. VLAN 10 exit, VLAN 20 exit, interface range fast ethernet 1/0/1 to 2, switch port access VLAN 10, and interface range fast ethernet 1/0/3 and 4, switch port access VLAN 20. So VLAN brief. So status of VLAN 10 and 20 is active. Active means VLAN is present in database. VLAN is present in database and VLAN is working fine. VLAN is present in database and VLAN is working fine. Suspend means what? VLAN is present in database. VLAN is present in database, but that VLAN is not in working state. That VLAN is not in working state. You generally you will not see suspend state, right? Because of any reason, if VLAN is not working fine, in that scenario only you will see a status is suspend. Inactive means VLAN is not present in database, but you know at least one port is member of that VLAN. Let's say, see this interface and this interface. These two interfaces are member of VLAN 10. And if I will delete VLAN 10 from here, say no VLAN 10. So VLAN brief. Now we are not able to see VLAN 10 and we are not able to see port also, like 0/1 and 0/2. 0/1 and 0/2 port are not member of VLAN 1, are not member of VLAN 20. Then where is 0/1 and 0/2? So this is because of inactive state of VLAN. Here we can run this command. So interface fast ethernet 1/0/1 and switch port. It will show me. Access mode VLAN 10 inactive. And shutdown means, let's say I want to shut down VLAN 10 on this switch. So manually I can shut down, like we are shutdowning the interfaces. We can shut down the VLAN to stop working VLAN on local switch. Suspend and shutdown both are similar, you know, both are like similar, but difference is shutdown is going to down that VLAN on a local switch and suspend is going to down that VLAN on all switches in BTP domain. On all switches in BTP domain. And to shut down, here you can run this command VLAN 10 and shutdown, or VLAN 20 shutdown. So VLAN brief. VLAN 10 and 20 are shut down. Like this we can say suspend also. VLAN 20. State suspend. Again, we cannot suspend VLAN 1 or we cannot shut down VLAN 1. Suspend means to suspend a VLAN in VTP domain, and shut down means to suspend a VLAN in on a local switch. And suspend, as I told you, suspend means VLAN is present in database but not in working state.
What is VTP domain?
So we will learn VTP protocol, right? Actually, let's say I have 100 number of switches, right, in my enterprises. And if you are thinking 100 number of switches is, large number of switches in enterprises, generally we will not have 100 number of switches. So guys, this is very less number, right? In a large enterprises network, you will say maybe 10,000 number of switches in one organization, right? So let's say you have 1,000 number of switches in an enterprise company and you need to create 2 number of VLAN on each switch. So see how complicated this task is, right? Creating 2 number of VLAN on 1,000 number of switches. That means around we need to run 4,000 command, right? We need to hire lots of engineer here. Then we will assign some switch, let's say 100 switch to one engineer, and right, they will start assigning VLAN. So that's why we come up with VTP protocol, VLAN trunking protocol. This protocol is VTP. This protocol is responsible to propagate VLAN information, right? You will create VLAN on one switch and VTP protocol will propagate that VLAN to all other switch. Okay, so in the VTP domain, let's say we have 1,000 number of switches, right? So if I will down one particular VLAN, if I will shut down a particular VLAN on a switch, that VLAN will be shut down on that switch only. But if I will suspend the VLAN, right, so it is going to shut down that VLAN on all 1,000 number of switches, on all 1,000 number of boxes. Done. So I have covered VTP protocol also. So really, this is only VTP. We don't have anything else. VTP is a protocol, layer 2 protocol, which is used to propagate VLAN information. That's it.
How to configure VTP in a switch?
We will see the configuration part in VTP.
Okay.
I was joking, right? VTP is still there.
Means VLAN uses that
By
VTP
default,
protocol, right?
But by default, VTP is enabled. So VTP status. See, by default, VTP protocol is enabled on switches. Domain name is CCNA. Now there are two types of VLAN: standard and extended. You need to learn the range, of standard VLAN and extended VLAN only. Types of VLAN. Okay, this is different thing. Range of a standard VLAN is 1005, 0 to 1 to 1005, and range of extended VLAN is 100. Sorry, This is range of, where is range?
Just to open the difference between standard and extended. That last. Go back. This down.
Range is here, but I want, bit explanation. So here you can see some difference. Range of extended is 1 to 1005 and range of extended VLAN is 1006 to 4094. Right? Extended VLAN allow basic network segmentation. Don't use VLAN trunking protocol like VTP. Created, this is wrong. Extended VLAN also use VTP. So see the Google. Yes. Range, then used for a small and medium size network. Extended VLAN is used for large network, right? Maybe large, for large enterprise or for ISP set. Generally we are using extended VLAN in ISP network, and we are using normal VLAN or extended VLAN in enterprise. Okay, in VTP protocol we have three version 1, version 2 and version 3. So normal range VLAN support all version of VTP, but extended VLAN support only version 3. Okay,
Can you open the second column, third one, third box, second column, third
this
box, second column, third box, this one? No,
this one,
down, down, the
this one,
next.
this one.
Yes.
Yes,
Yes. We use still 1001, right? To normal.
yes, 1 to 1001
So
for
three
extended.
for 345, we normally don't use, huh?
VLAN 3.
No, 1003 to 1005,
No,
1002 to 1005.
no, those are reserved. Like VLAN 0 is also reserved. VLAN 4095 is also reserved. We are not using those VLAN. Those are not in use. VLAN 1 is default VLAN. This is the range what we can use here. Normal range. Cisco default for FDDI and token ring. You can't delete VLAN this to this. Extended VLAN for Ethernet VLAN only. Okay, so simply you can say extended VLAN is used for enterprises and extended VLAN is used for ISP, right? For large network, range of extended VLAN is, main thing is range. Range of extended VLAN is 1 to 1001 and range of extended VLAN is 1005 to 4096. And see, rest VLANs are still here on switch. So VLAN brief. VLAN 1002, VLAN 1003, 1004 and 1005.
So
These are still there on switch, but for different technology, right? This is reserved for token ring, right? So we are not using token ring technology nowadays. This is not in use. Earlier we were using. Like, a few days back we had discussed DMVPN or GRE tunnel, right? I'm not saying we are not using VPN or DMVPN. Still we are using, but most of the organizations are moving on SD-WAN, on automation network. Their DMVPN is not required. Like that, earlier we were using token ring, maybe for any purpose. 1003 VLAN is reserved. Okay, for different purposes these VLANs are designed.
So we can create VLANs from 2 to 1001 standard VLANs.
Why we can create extended VLAN also now on switches?
Yes. For standard
We
I'm
can,
telling. 2 to
yes, for a standard, correct. Okay, VLAN. What it's saying, this is extended VLAN, and as I told you, extended VLAN can be configured on VTP version 3. So current mode of VTP is maybe version 1 or version 2. So VTP version. So VTP status, sorry. Version is 2. VTP version 2. So that's why we are not able to create extended VLAN on this switch. If I will change the
The
version,
mode is in server mode, maybe.
no. On okay, if you want to create, you have one again more option. You can configure extended VLAN on transparent mode switch also. So here VTP
Yes.
mode and transparent. Okay, setting device to VTP transparent mode. Now if you will check do so VTP status, now you can see mode is transparent. And now if I will try to create extended VLAN 104093, let's say, so see, now I am able to create extended VLAN also. So we can create extended VLAN in VTP version 3 or on a transparent mode switch. Now if you are thinking what is transparent mode switch, so we will discuss it in VTP. In VTP we will discuss 3 types of switch: client mode switch, server mode switch, and transparent mode switch. Done. So VLAN brief. Done, guys. Any question from VLAN? Any other question from VLAN? Can I move?
Yes, sir.
So I really wanted to do one practical examples.
One practical of VLAN.
export VLAN and import VLAN to another switch.
We will perform
Maybe in
practical of
tomorrow.
VTP, VLAN trunking protocol, VTP. In that I will cover VLAN also.
Okay.
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 Don't worry. This is like, basic VLAN. What is VLAN? How to configure it? How many types of VLAN states are there? Theory part completely. These things are clear or not?
Got it. Clear.
To all. Now, guys, I want to make you understand first, before discussing anything else in switching module, what do you mean by switch port and what is the output of this command. So interface fast ethernet 1/0/1 and switch port. Actually, with the help of this command, we are going to check layer 2 information of this port, layer 2 information on this port. So first of all, let me discuss the output of this command, right? How many layer 2 protocols are running and what are the role of this port at layer 2. So see, switch port means what? First of all, switch port means port of port of switch. Switch port means what? Port of switch, right?
Yeah, it means the port is in layer 2.
Yeah, switch port means the port which forward traffic on the basis of layer 2 information. That port is known as switch port. Port which forward traffic on the basis of layer 2 information. Like Now this switch is forwarding packet on the basis of traffic on the basis of layer 2 information, on the basis of MAC address table. So all ports of this switch is called switch port. All ports of this switch are switch port. So interface fast Ethernet 1/0/1 and switch port. Switch port means something related to layer 2. See, switch port is enable, means layer 2 forwarding is enable. Guys, on this switch, administrative mode is dynamic auto. That means administrative mode means administrative means engineer, network engineer have manually configured this port as dynamic auto. Means manually engineer have run one command on this interface. One command is already enabled on this interface, that is switch port, mode dynamic auto. Getting my point? This command is by default running in the iOS, right? Let's say you have just purchased one fresh switch from the market and you have run this command. So interface 1/1, so 1/0/1 and switch port. You will see administrative mode is dynamic auto. That means this is in configuration by default. Okay, but we can change the mode. But now we have configured dynamic auto. This is in running configuration. Okay, if administrator have given this input dynamic auto, then what is operational mode? Means operational mode means how switch is going to work. What is operational means output. What is output of this input? So output operational mode is static access. Now there are two types of switch port. Switch port is port which forward traffic on the basis of layer 2 information, and there are two types of switch port. First one is access port, and second one is trunk port. Access port is the port which is member of single VLAN, and trunk port is the port which is member of all VLAN, right? That means whenever we will put this command on the interface, switch port mode on dynamic auto like this, then my operational mode is going to be static access, or it can be trunk. As I told you, there are two types of switch port. It can be access or it can be trunk. After that, it can be static access or it can be dynamic state. Operational mode can be, let me tell you here, operational mode can be static access, it can be trunk, it can be wait, we will discuss two more operational mode here. But before that, what I am saying here, administrative mode is dynamic auto by default, and operational mode is by default static access. Okay, let me change administrative mode on this interface fast Ethernet 1/0/1. Say switch port mode access. By default command which is running in the default running configuration is switch port mode dynamic auto. Here I have said what? Switch port mode access, and do so interface fast Ethernet 1/0/1 switch port. Guys, is there any change in operational mode? What happened? Administrative mode is still dynamic auto. Here I have configured manually switch port mode access, or let's say access dynamic. Okay, so access So why it's not changing then? Huh? Wait, interface f1/0/3 switch port mode access. So interface f1/0/3 switch port. Now administrative mode is what? Static access. Default configuration, administrative mode is dynamic auto. Yes or no? Dynamic auto is using a protocol that is DTP, dynamic trunking protocol. We will discuss about that protocol also later. But here, if I am setting administrative mode static access, then also my operational mode is static access, right? If interface f1/0/3 switch port mode trunk, switch port command is rejected, but this interface is member of VLAN 10. Switch port mode access, mode trunk. An interface whose trunk encapsulation is auto. Okay, switch port trunk encapsulation .1q and switch port mode trunk. Now here I have set administrative mode is trunk, and now again I am going to check the switch port of this interface. So now administrative mode is what? Trunk. Then operational mode is what? Trunk. Now this interface is operating on trunk. Earlier this interface was operating on access. That means earlier this port was member of single VLAN, and now this port is member of all VLAN. All VLAN or maybe multiple VLAN, because we can exclude some VLAN also, but by default this interface is member of all VLAN. Okay, so interface f1/0/3 switch port mode, and see my mode can be access. Means if I will configure here access, then operational mode is going to be what? Static access. Yes or no? Operational mode is going to be static access. If I will configure here trunk, then my operational mode is going to be what? Trunk. Yes or no? But if I want to use protocol for this mode, then I will use keyword dynamic. That means I am calling to DTP protocol, right? And guys, DTP protocol is used to form trunking between switches, right? Tomorrow we will discuss DTP protocol first. Okay, so DTP protocol is used to form trunking between switches automatically or dynamically. Otherwise, again, let's say we have 1000 number of switches and we need to configure trunk link between switches, then again this is complicated task. So we have one protocol to form trunking dynamically. But in static we have two method, two mode, two administrative mode. It can be access or it can be trunk. So if I will assign administrative mode access, then my operational mode will be access. If I will define administrative mode trunk, then my operational mode will be trunk, right? Operational mode is trunk. So administrative mode can be access, it can be trunk, it can be dynamic auto, or it can be dynamic desirable. So difference between dynamic auto and dynamic desirable we'll discuss tomorrow, right? Today we discussed static method. In static we have two methods, right, to configure access port or dynamic mode. So I can't change operational mode, right? Switch will automatically change operational mode. I will only define administrative mode here. Fine. After that, administrative trunking encapsulation, we will discuss this also tomorrow. And again, here you can see we have two mode. One is administrative mode. So whatever input I will define over here, according to that input, it will automatically choose operational encapsulation protocol. That what will be the encapsulation protocol. So again, we have two encapsulation protocol, ISL and .1q. So we will see how many options we have to define encapsulation trunking encapsulation protocol, and then what will be operational mode. For now here this interface trunking is enable access mode for VLAN 20, but VLAN 20 is suspended, right? So there is information of VLAN 20, means this port is member of which VLAN. Trunking native, okay, we will discuss about this also. Native VLAN tagging is enabled, okay, this is not for us.
What is that pruning VLANs enabled?
We will discuss in BTP that also, pruning. Pruning is what, let's say switch 2 is connected with one another switch 3, right? And here also again we have some users, and we have trunk link between these two switch. We have trunk link. So on trunk link are member of all VLAN, means this interface and this interface are member of all VLAN. So now let's say here is one user whose IP address is 10.1.1.10. So 10.1 means router 1, 10.1.1.1 want to communicate with 10.1.1.10. So source MAC will be MAC address of router 1, and destination MAC will be the MAC address of 10.10. It will forward traffic to switch. Switch will check what? Switch will check their MAC address table. First it will learn source MAC address, then it will check their MAC address table. In their MAC address table, if entry is available, then entry can be on the ports which are member of VLAN 10, or it can be on trunk link. Means when how switch 2 will learn MAC address of this device? On trunk link, on this link. So switch 2 will forward traffic from trunk link, right? If trunk link is exist on this switch, if trunk link is exist on this switch, and let's say these port are VLAN in VLAN 100. So if trunking is enabled on switch, then if switch will not found any entry in their MAC address table, then it will forward one copy from their trunk link also, because trunk link are member of all VLAN. So it is doing unknown unicast flooding from trunk link also, right? So it will forward traffic from trunk link also. And let's say on this switch VLAN 10 is not exist. VLAN 10 is not exist on this switch. Then first of all, why this switch have received traffic of VLAN 10, right? It should not receive traffic of VLAN 10, because VLAN 10 is not exist over here. And if there is again one trunk link on this switch, then this switch will forward that packet from trunk link. That packet from, it will perform unknown unicast flooding over here. It will check their MAC address table, right? So see guys, if I am very sure that this interface is not connected with the user who is in VLAN 10, right, means this switch never need to forward traffic in VLAN 10 from this trunk interface. So for that scenario, we will enable VTP pruning, so that this switch should not send traffic of VLAN 10 from this trunk link. Or VLAN 10 is just an example, okay? In VTP, we will discuss with pruning also, and we will configure it also. Today we have just discussed MAC address table of switch, right? How many options we have to configure MAC address tables, right? A static method, dynamic method, MAC aging time. Then we discussed SDM, switch database manager, means how we can increase a space for switching purpose, right, on the switches. Then we discussed VLAN, and after that we discussed what is switch port. Okay, in next video tomorrow we will start with trunking, right? First we will understand the requirement of trunking, and then we will see again configuration. Now whatever protocols we are going to learn, right, we will have two options. Like VLAN, configuring VLAN, we have two options: static, dynamic. Configuring routing, we have two options: static, dynamically. Either I can configure routing protocol, or either I can manually define networks on the router. So in switching also, to configure VLAN, we have a static method that we discussed, and we have dynamic method, that is BTP protocol. For trunking, either we can configure trunking between switches manually, or we have a protocol. We can use protocol. So first again we will learn a static method first, and then we will discuss about protocol, and after that we will implement that protocol in switching module, and this is how we will move to next protocol. Okay. like you learn routing, in the same way you have to learn switching also, because in switching again we have multiple protocols, and we need to learn these all protocols very carefully, because these are very important protocol. Whatever things we have discussed in routing module, really guys, I am really telling you, those all protocols are very important in industry. If you have understood those protocols clearly, you can understand other technology also easily, right? Means if your routing funda is clear, right, SD-WAN is just 20-hour content for you, just 20 hours content for you. In 20 hours you can learn SD-WAN, and you can implement lab as well by yourself. So in the same way, again we need to focus on switching module now. What are the basic protocols, basic funda of switch, how switch is forwarding actually packets, right, how switching protocols are working, why by default these protocols are enabled, if by default these protocols are enabled, then how protocols are working by default, right, what is the role of that protocol. Getting my point? Like if VTP is enabled by default, then if I am connecting to switch, then why VLAN is not propagating, right? You have to understand it. So again, try to, because now we are discussing basic things, so you need to put your some time as well to read some books if you are getting some doubt, like what is VLAN, or in basic switching. And once you will get the basic concept of switching, I can make you understand advanced protocols like STP, ether channel, load balancing in the ether channel. Those are again advanced things and important things easily. You will catch everything easily. Okay, so for next 10 days, try to spare some time for switching module, right? Then I am damn sure you are switching, you will never forget these protocols or basic switching in your life, like routing. If you have attended all my class of OSPF, brother, doesn't matter now you have types of messages in your mind or not, but if you will open any book or your notes, if you have maintain note, easily you can read there, and you can recall everything there, like these are the messages, how these messages work, right, how routing protocols work, how LSAs work. I have some friend who did CCI twice. Even sometimes he is not able to explain LSA 7 in OSPF, because when we learn, and after some time, if we will not revise, we will forget everything. We will forget everything. He know LSA 7 is used to forward prefixes in NSSA area, but he don't know what is the all concept of LSA 7. So no one is there who have complete thing in mind, but basic funda should be clear, right? We should have one understanding, so that we can read from book also, or we can check things on Google also, like I also don't know, sometimes you see command, what is command, right, and I am checking it on Google. What is the range of extended VLAN and extended VLAN, I am checking it on Google. But if I don't know there are two types of VLAN, right, then I can't check what is range of extended VLAN and extended VLAN. Getting my point, Vasavaraj? Yes or no?
Yes, Ji.
Okay,
But
then
you
that's all
explained
for
very well,
today.
Ji.
Yes.
Actually, we understood thoroughly.
Yes. Okay, guys, then that's all for today. Let's meet tomorrow. Thanks for joining. Tomorrow we will continue from trunking. Okay.
Yes, Ji. Thank you. Thank you so much.